let us take a problem which can be solved using the Kirchhoff's law. Here you can look at the circuit. In that circuit, we have to find I1, I2, I3 and I4. And the value of R1, R2, R3 and R4 is given. And the EMF E1, E2, E3 is also given. And that you can see below. Next, I have redrawn the circuit here. I have just put the value at their own place. After that, I'll apply the Kirchhoff's current law at the junction B. You can look at that. In that circuit, I1 is an incoming current to the junction B, and I2 and I3 are the outgoing current from the junction B. If I take incoming as in positive, then I2 and I3 has to be negative. Therefore, in this case, according to the Kirchhoff's current law, I1 minus I2 minus I3 will be equal to 0. And that I am showing here. You can see here, this is the equation number 1. Another thing is that here in this circuit, I1 and I4 are the current in the same branch. Therefore, these two currents are same. Therefore, here I am showing I1 equal to I4. Now, we'll use the Kirchhoff's voltage law at the mesh B, C, D, E, again B. Now, current's direction already has been given. Now we'll take a mesh current directions. That means closed loops current directions. It is your wish at which direction you can take anti-clockwise or a clockwise directions. Because I have taken here, I am showing I have taken a clockwise direction. Therefore, my movement would be from B, C, D, E, again B. Now you can see as we move from BC, there is no current, no resistance, and there is no EMF. And as you move from C to D, first you encounters the 10 ohm resistance. And this is, now we are moving in the clockwise directions. Therefore, we are moving along the branch current directions. Therefore, it would be we are moving from a positive higher potential to lower potential. As you know, if we move from a higher potential to lower potential, it would be negative. Therefore, it would be minus 10 I2. And then as you move to the EMF, again you are moving from a positive terminal to negative terminal. That is higher potential to lower potential. There also it would be negative. That means minus 10. And then as you can see D, there is no resistance and there is no EMF. Now you come to the EB. As you move in from here you are moving from a lower potential to higher potential. Therefore plus 8. Now here in this 5 ohm resistance you are moving opposite to the branch current. Therefore plus 5 I3 and equal to 0. That I am showing here. This is the equations, and after that small simplifications, you will getting the equation number 2. Now you come to this another closed loop, that AB, BE, EF and FA. Now I am showing here in this, it is also clockwise direction. Therefore, as you move from A to B, you are encountered a 20 ohm resistance and you are moving along the direction of current. Therefore, it is minus 20 I1. Now B to E, you are moving along the direction of current. Therefore, minus 5 I3. Now as you go you are going from a higher potential to lower potential. Therefore, minus 8. Now here you are coming from, in this EF branch, you are coming along the direction of current, therefore minus 15 I4. And then as you come from FA, it is, you are coming from a negative potential, negative to positive. That means lower potential to higher potential, therefore plus 20. Therefore you get this equation here. Therefore here you get this equation, all are minus except plus 20. Now another thing is that after simplifications, I4 already I told, I4 and I1 are the same. Therefore I4 has been replaced by I1, and after simplification we'll get this equation. And then another thing, I1 is replaced by I2 plus I3 from the equation number 1. Therefore we'll get this equation. And from this equation 2 and 3, if we combine, we'll get a matrix. We'll get this matrix, and after getting this matrix, we can use the Cramer's rule in the determinant, and using the determinant Cramer's rule, we can solve these two equations and get I2 and I3. We can get I2 and I3. We got I2 and this is the I3. And then I can find I1 from the equation number 1. And that is all about this problem.